Okay, we're gonna do the potato osmosis lab. And you guys, when you watch this, know that there's 3 different variables that you could choose. I'm gonna choose, for me, what I think is the most interesting, the surface area to volume ratio, and that as my variable. So these here are going to be, these set of potatoes, these small ones, are 1 cubic centimeter. These are 1.5 cubic centimeters, and these are 2 cubic centimeters. So I'm going to predict that that 1 cubic centimeter, that's going to be the fastest rate of osmosis. That's my prediction. And I know that because the smaller you are, the higher your surface area to volume ratios are. The surface area starts to decrease relative to volume. Volume, it grows more rapidly than surface area. So these are going to have less surface area relative to their volume. So that should slow this down. Now, you don't have to choose surface area to volume ratios. There's 2 other factors that can affect the rate of osmosis. Now, you'll have to control for surface area to volume if you choose another variable. If you choose another variable, say it's concentration gradient. So instead of, these are all going to be in just pure water. These are beakers with 100% water. This is distilled water. It's 100% water. These obviously are going to have solutes inside. I mean, they're potatoes. They have salts and other solutes inside of them. So they're going to, water's going to diffuse into them. They're going to gain mass. All of them are going to gain mass, but these should gain mass more quickly. So I'm going to be, rate is going to be, or my percent, I'm going to do percent change. Percent change will be my, I guess we could analyze it in both ways, rate and percent change, but I'm going to do percent change at least on the spreadsheet. And if you want to use rate, you're welcome to do that if that's what you'd like to do instead. Nevertheless, so these are all going to be pure water. I'm not going to have any difference in my solute concentration, but if you were using solute concentration, all these would have to be the same size. You'd have to control for surface area to volume ratios. So these could all be maybe 1 cubic centimeter or 1.5 cubic centimeter, whatever is easier for you to cut. You're going to cut potatoes of your own. You're not going to use my data. You're going to do it yourself. I think that'll help. Last time you watched me do it, and I don't think that went quite as well. So in order to do this, we need to take the initial mass and the final mass. Now, you can see all my little potatoes have flags on them. I need to make sure that I know, because they're all cut exactly the same size, that I know which potato is which. And you'll have to do the same thing. What I did is I just simply got a needle or a pen. I put a pin on the top and I made a little flag out of tape and wrote their numbers on them. And that way, when I take the mass, when they come out, I know which one I'm measuring. So we also need to keep other things constant, or controlled variables, or be the amount of time they're in this, I would say, solution, but it's not. It's just pure water. Temperature is the other variable that you could, if you wanted to keep concentration of the solutes the same, instead of having maybe 5% salt, 10% salt, and 15% salt, or 5% sugar to 10% sugar to 15% sugar, if you want to make a solution like that. If you wanted to make it, temperature is your variable, it'd be a little more difficult. You'd have to maintain a temperature, so you'd have to have a hot plate or something. That might be kind of hard to do. So I recommend you guys either use solute concentration, which is what most people do, or if you really want to get adventurous, you could do surface area to volume ratios. And so that's what I'm going to do. So I'm going to let you guys watch me take a data. I'm going to write it down, and then I'll transfer it over to a computer. Well, I'll pause the video, and then I'll wait 1 hour, and then I'll come take data. So first things first, I'm going to write all this down. I'll start with my large group. Excuse me. And inhaled the apple a moment ago. So I'm going to do 10 first. I'll do 10. 15.2. So this is my initial column. This will be my final column. 15.2. Put it back. Get 9. 9.6. And it doesn't matter that they're slightly different in their mass. They should be relatively constant because I cut them all the same size. 12.0. And they're not going to be perfect. And I'll cut one for you. You'll see. They're not going to be perfect. 7 is 10. And I'll show you how you can get, and I know you don't have a scale. Most of you guys don't have a scale. I'll show you a way that you can do this without having a scale. If you have a scale, you can use it. 10.6. Scales just make it really convenient. 10.2. I'm going to go 4. 10.9, 3, 10.5. 2 is 10.5 as well, yay. I was really accurate on this one. This one's a little bigger, it looks like. 12.8. So all these are ready, and then I'll go to my next group, my 1.5. So these are all 2 cubic centimeters. So let's go to this group. 5, this is 10, so 5.2. 9, 4.6. Let me make sure this is recording. It is 4.6, 8, 6.3, 7, 5.3. Actually, that's not, okay. This is 2, put it in the right location. 5.6, 6, 5.4, 5, 5.3, and 4, 5.5, 3, 5.8, and 1, 6. So these are, and my units are grams. Okay, now we're going to do this last group, this one that are 1 cubic centimeters. These are 1.5 cubic centimeters, 2 grams. 2.1 grams, 8, 2 grams, 7, 2.1 grams, 6, 1.9 grams, 5, 1.9 grams, let's see, there's my 4, come on buddy, you can stand up, 2 grams, 3, 2.6 grams, man, this guy's heavy, 2.1 grams for number 2. That one might have had a little more tape on it. Obviously, I'm taking the mass of the tape and the needle, but that's not a problem because we're just, only place that osmosis is going to be occurring is in the potato. And then 2.3 grams for number 1, 2.3. Now what I have to do is get them into the solution. And I need to do it close to being the same time. It's going to be hard for time to be an absolute constant. I'm going to have to do it pretty quickly, but I don't want to do it where I knock off my little flag. So I'm going to take these now. I'm going to set a time. The time is 1:50. That's when I start my trial, at 1:50. So let me go ahead and place these guys in here really quick. Be really gentle with them. And I'll take them out first. When I end the trial, I'll take these out first to control for the situation to where they might have been in a little longer. Well, I'll take them out first. These guys won't be in any longer or shorter in terms of their trial time. So this is gonna be, maybe you can see that a little better. Taking these and putting them in here. They're all standing up like little soldiers. Da-da-da-da. And I've got that pin in there pretty firm. That pin's in there pretty firm. Boy, these are getting kind of crowded. That 2 centimeter group is going to be a booger. Ooh, came out. I'm gonna make sure they're all the way submerged. That may be a big problem for my next group. All right, so here we go for the other one. So get them all bunched in here. Whoa, don't get away from me, buddy. Woo! I'm increasing the surface area of that one because I stabbed another hole in it. So, see if I can get this one to be completely submerged. Come on. There we go. Okay, they all fit. Okay, so what do you do if you don't have a scale? So something that you could do instead, let me see where. Something that you could do instead, and I'll take this data and move it out of the way. 1 cubic centimeter. So these are 1 cubic centimeter to 1.5 cubic centimeters, 2 cubic centimeters. That's my independent variable that I'm going to use. Again, you can use whichever one that you want. I'll set that to the side. So what do? I don't have a scale, Mr. Pope. What am I going to do? Well, use your old noggin. These will, not only are they going to increase in mass, but they're going to increase in size. Their volume and surface area themselves are going to expand. If they take in water, they're going to have to get bigger. So we could you could cut these and then measure these. So I already cut these. These are pretty small, but I'll show you how I did it. And I'm going to look. Yeah, may take a little time. In fact, I'm going to start over on this one. Let me cut this potato. See how it's kind of slanted? Let me cut this potato straight down. There you go. Now it's not slanted, so it's not diagonal. I'm going to come here. I'm going to find one. And again, we're not going to use inches. We're yet to use metric units. So I'm going to score it. That's where I'm going to cut. That is 1 centimeter. So I'll cut a slice. Now be careful about it. You guys aren't kindergartners. You're not going to cut your finger off. And now I'm going to cut the edges off. I don't want the skin. That's like an extra membrane, an extra way for it to get in and out. And I'm going to, there's a little bit of extra here on this diagonal, so I'm going to diagonally cut. There we go. Get that out of the way. There's 1 centimeter there. Another centimeter here. And I know that you guys, it's going to be really, really rough you're going to be measuring really small changes, but you want to try to get as close to 1 centimeter as you can, because the difference when it gets larger, especially if you use one that's small like this, I mean, maybe small is actually going to be the best because it's going to expand more quickly. It may be from 1 centimeter to 1.2 centimeters. And so the difference is only going to be 0.2 centimeters, which will be 2 millimeters. So let me get that cut there. That's 1 cubic centimeter. 1 cubic centimeter. That one wasn't quite 1. And that's 1. And that's 1. So all these are the same size. They're 1 cubic centimeter. No matter how I turn it, that one might be slightly off on one side. But cut these, and you can use a razor blade if you don't have. I have an extremely sharp knife. This knife, you can castrate a gnat with that thing. You could use a razor. A razor could do it as well. You could maybe, if it's this one was a little long, looked like it was 1.1 or 1.2 centimeters. I could shorten it because it wasn't perfect. Just take a little slice off. So now it's actually it's a cube, perfect little cube. And this one's a little longer as well on one side. There you go. the more accurate you are, the better. So cut with precision. So what we're gonna do is I've got a timer set at 250. I will take these out and I will see the results and we'll record them and then I'll show you guys how to analyze them. All right.